Question 2, consider the sequence 73, 67, and then 61. Part A says write the next 4 terms of this sequence. So as I look at it, it seems to me that each time I move forward, and I can clearly see this in both of these steps, I'm decreasing by 6. So I can say I'm adding -6 each time, or I'm subtracting a +6. So knowing that I'm decreasing by 6, I can go ahead and write the next 4 terms. So for example, 61 minus 6 would give me 55. And if I subtract 6 from that, I'd be at 49. And if I subtract 6 from that, I'm at 43. And subtract 6 from that, and I'm at 37. So this is how it continues. B says, what is the generator of this sequence? So as I said in class, the generator has 2 parts, right? It's not just the number, but it's also the operation. So in this case, the generator is I am adding, and I'm going to use that word, adding -6. So, and it's important that I distinguish, because if this was a geometric sequence, my generator would involve multiplication. So it's not just enough to say the number that you're using, but what operation you're doing it with it. So each time here I am adding a -6. And the next part is, what kind of sequence is it and how can you tell? We know that this is arithmetic. And I can tell because I am, in this case, decreasing by a constant value. I'm not using repeated multiplication. I just keep subtracting 6, or adding -6, adding -6. And then the last question says, what is, C says, write the explicit formula for this sequence. So 2 things we need to know is the 0th term, which correlates with our y-intercept. And if I look at this sequence, I can see that the first term is 73. So if the first term is 73, right, and then the second term after that was 67, etc., I need to know, and this is not part of the sequence, but I need to know that the value of the term that would come before the first term, the 0th term. And instead of subtracting 6 to move forward, I'm going to add 6. So this would be 73 plus 6 would give me 79. So that's my 0th term. And again, I'm decreasing by 6 each time. So the explicit formula is for the sequence. If I use this notation, I could say it is T of n is equal to -6 times n, and then plus the number 79. And you know, it's always nice to just think about this momentarily. If I put the number 1 in for n, right, T of 1, the first term, better be the number 73. And yeah, sure enough, if I look at this, this is -6 plus 79, and when I simplify it, it is indeed 73. So this is the correct explicit formula, not the recursive formula, right? If I was to look at the recursive formula, we need 2 things. We would need to know what the one of the values is. So I could say that T of 1, like the first value, is 73, and then we need to have what we call our recursive rule. So I could say that the next value in this sequence, T of n plus 1, is the value that I'm currently at, T of n, and then I just decrease that value by 6. So my recursive definition needs both of these, a place to start and how we proceed to new terms. So it's kind of nice to review both of those, because you know, we never know which way would be most convenient, or you know, we've seen situations where we couldn't come up with explicit formulas and we had to be satisfied with the recursive definitions. So that's the end of question number 2, and you can see the parts there. Let's move on.